Good afternoon, everybody. Thank you so much for joining us today for another EI Live K-12 session for students and educators, brought to you by the Earth Institute at Columbia University. My name is Cassie, and I'm the Director for the Office of Education and Outreach. And a big part of my job is bringing our scientific research to different audiences, including K-12 students and educators. So for those of you who are joining us today for the first time and may not be familiar with the Earth Institute, our core mission is to foster greater understanding of the science behind sustainability and the climate crisis and what we as global citizens can do. Experts that make up the Earth Institute include earth scientists, economists, business and policy experts, and specialists in public health and law. The Institute is actually made up of more than 24 or so research centers and several hundred people who collaborate across many different departments and disciplines within Columbia University. What we're hoping to do with these sessions is to introduce you to our interdisciplinary work through our experts. We'll have sessions until the end of June for K-12 students and educators, and we'll also be expanding on the EI Live series to include additional live stream content. Today, we're going to hear from Dara Mendeloff of the Center for International Earth Science Information Network at Columbia University. She's going to be leading us through a demonstration of GIS and some introductory basics related to GIS so that we can better understand how scientists and experts like Dara use maps to explore social and environmental processes. So as a reminder, please use the chat box just to the right of this video for questions only for our presenter. We'll be monitoring it throughout the talk, and once Dara is done her presentation, we'll go through all the questions. You can also feel free to email me the questions directly, and feel free to just type the questions throughout the presentation. We'll make sure we scroll back and get everybody's questions answered. If you did not get my emails with the maps that we're going to be looking at for today's session, please send me a note very quickly to the email that I shared with you when I provided this live stream link. It's not the end of the world, so don't worry about that. And we will go through the exercises. So if you have any questions about that, or if you're having technical difficulties, please also email me directly. So without further ado, I will hand it over to Dara.
Good afternoon, everybody. Can you hear me okay?
Yeah, we can hear you.
So thank you so much for inviting me to do this session, Cassie. I really appreciate it, and I'm really excited to share what I do with all of you people. So like Cassie mentioned, I work for a research center under the Earth Institute called CIESIN. We're the Center for International Earth Science Information Network. And I am a geographer, a geographic information specialist. So I'll tell you a little bit about what that means. Some of you might have heard what GIS is, and so I'll give you a little introduction to what that actually means and some applications to it. And then we're going to do a fun exercise together, 2 fun exercises together. One for exploring the Environmental Performance Index, and another looking at noise in New York City. So at CIESIN, we look at the intersection of humans and the environment. What does that mean? So where do people live? What kind of lands are endangered? What's the human influence on certain types of lands? We look at things like infant mortality rate, and how can that become an indicator for something like public health? I've also worked on projects looking at water quality. At the bottom right of this image, you're looking at water quality in Jamaica Bay. Often we go there for recreational purposes. Some people use it for fishing habitat. But how good is the water, and what is the trend of water conditions over time? We look at those kind of issues. At CIESIN, we host a NASA data center called SEDAC. It's the Socioeconomic and Data and Application Center. Lots of acronyms might be thrown at you, don't be scared. Here we look at the human and environment interaction using satellite and remote sensing information. So At this image, we're looking at a map viewer. So on the left, we have something called the Environmental Performance Index. On the top right, we have PM 2.5. That's, I'll explain that later. On the bottom right, we have the human footprint. And on the bottom left, we have infant mortality rate. So a researcher or somebody in the education field might want to know, how are those things related together? So you might come to this application and look at, oh, look, well, we'll talk about patterns later, but that's an example of the kind of products that we produce and how you might engage with them. One other thing that we produce at SEDAC is a hazards mapper. So what we're looking at here is a population distribution in blue. So you get to see the darker the color blue, where more people are living, the lighter color blue, less people are living there. Some people might be interested in saying, okay, the green dots or the green symbols are earthquakes. Also, we have nuclear power plants. Whoa, how are those things related? Well, if an earthquake occurs, you might want to know what kind of nuclear plants are in that area and how many people live in that area, just in case that's a hazard and potential disaster. So using this application, you can zoom into your area of interest. So I zoomed into New York City here, and there is a nuclear plant up in Indian Point. And in this application, you're able to draw what did I draw? A 30-kilometer circle. And I calculated, well, this application calculated how many people are within that area. And about 1 million people are in that area. So somebody who's in risk management or emergency services might be interested to know the quantity of people that are in danger from the nuclear plant responding to that earthquake. I work on some other types of information. Currently, I'm working on this food insecurity hotspots data set. So where are food insecurities? So where are people not getting access to food? Where is there some sort of stress? Where might there be famine around the world? So this data set is looking at where those areas are. Some colleagues of ours at the Nature Conservancy has put together a couple of very interesting data sets about the human footprint. So what is the influence of people on the environment? So this is the human footprint as of 2009. So the darker the areas, the less the dark blue is a lower impact and the dark red is a higher impact. Those same colleagues also were interested in what is the potential threat to the future of development. So using information about agricultural expansion, urban expansion, activities in mining, energy development, such as oil, gas, coal, biofuels, solar, and wind. Where are those activities potentially going to be developed in the future? This is development potential indices for specifically biofuels, similar to what I was just talking about. Here's an example of just where people live. Using the census data of, this is an example of 2000 census. One of our flagship data sets at SEDAC is the global population of the world. So we're very well versed in just identifying where people live. Here's an example of where people live in New York City. You have the percentage, so not just where people live, but the socioeconomic and demographics about those people. So percentage of people living 50% below the poverty line, the average household income. So we talk about income, we talk about race and age, and all of that information. Here's an example of the Jamaica Bay water quality database that I was telling you about. So the type of conditions, we're looking at variables that range from temperature to fecal matter, lots of different variables. Most recently, I was looking at mapping sustainable development goals in a mining community in Chile. This is a very interesting project. When hurricanes and tropical storms occur, just like I was talking about the nuclear and earthquake disaster issue, flooding is a huge concern these days. So flooding and sea level rise. So we want to know things like who was affected, how much land was affected, and what's the distribution of all of that impact. GIS and mapping can also be applied to planning and urban issues. So here's an example of zoning in New York City. This map shows you where you can develop, what you can develop, commercial, residential, all of those type of land use types. This is my favorite map. This is a map that NOAA produced several years ago. This is, I forget, about over 150 years of hurricanes. And it's a pretty map. It is very simple. We'll talk about mapping in just a moment. But it's a very complex data set, 150 years of information, but it's a beautiful map. So to conclude, I think I'm concluding, applications of GIS are everywhere in weather and climate, health, crime, asset management, agriculture, hazards. It's everywhere around us. So what is this GIS thing that we talk about? It's not just map making. It's really how do you understand the spatial information, the data around us, in order to produce maps and applications that are useful for solving problems. So it is a combination of maps, the visuals, and tables. So in this image, we're looking at just a map that is directly linked with a tabular data set. And we use that link of the map and table to describe processes, to identify those patterns that we were looking at, where things are, when those things occur. We're going to talk about noise and when noise is occurring in New York City. So interesting, right? How are those things related to each other? And if you wanted to develop something, where might be a suitable area to develop? So once you have that connection of the map and the tabular information, you can layer those things on top of each other in order to create a map. Like a map the subway map has several layers of it. So in this image, we're looking at streets, water, parcels, and soils. Each one tells us something different about that area. But when we combine them, it gives us one solid map. And we all can make different maps using this information. So you're going to have the chance today to use different layers. We're all going to use the same layers, but you can make your own map and tell your own story. Here's an example of GIS data. So you have the United States. So there's about 50 states. You have a table that's linked to those states. And in that table, you have different descriptive information, right? We call this attributes. You have the name of the state. You have how many people live in that state. You have how many people live in that state in 1990 as well as in 2000. You have the area, the land area of that state. You have how many people live in a household. You have income. You have lots of different information about that state. You can then make several different maps. You can make a map of just the population 1990. You can then make a different map of the population in 2000 and compare the two. So there's a lot of things going on here in this GIS. So for the exercises that we're going to work on today, we're going to start with looking at one of SEDAC's data sets called the Environmental Performance Index. What we're looking at here is the final map. It's symbolized in purple, so the lighter the color purple, the lower the Environmental Performance Index. The darker the color purple, the higher the index. Something very standard in maps, right? Usually the darker the color, the higher the value, and the lighter the color, the lower the value. You have some labels that help you to identify what country we're looking at. So up here is Canada, you got Australia. It looks very simple, maybe. But the data set behind it is quite complex. So in order to create the Environmental Performance Index, in order to rank countries and compare countries amongst themselves, we're looking at two different categories, looking at environmental stresses on human health, and then we're looking at how well the country promotes ecosystem vitality. And in order to, there's a whole other category of variables under there, looking at air quality, water and sanitation, heavy metals, biodiversity and habitat, what's going on with their forests and fisheries, climate and energy, air pollution, water resources and agriculture. So the EPI, or the Environmental Performance Index, is composed of all of this wealth of information. So we're going to look at that today, starting with a map that looks like this. And we're going to produce something that looks like this. So that's one exercise. We'll start that in just a moment. And in order to produce this map, we're going to learn about the basic GIS functions of how you obtain information, identify patterns, and interact with the GIS. The second exercise that we're going to look at is, I think, quite fun. So given our situation these days, nobody's really going outside much. There isn't much construction going on. So you would expect that noise in New York City or anywhere in the world isn't a problem. So we're going to explore, is that true or is that not true? I don't know. This map is looking at the majority of noise complaints in New York City during the first week of May, which was last week, the 1st to the 8th of May. And you can see that the majority of complaints through 311, which I'll explain to you in just a moment, is loud music and party. Other complaints are car and truck horns and noise construction before or after allowable hours. And on the map, you get to see not just what the categories are, but where these things are happening. And if you're familiar with New York City, you can see that out in eastern side of Queens, in Fresh Meadows, is where there's car, trucks, and horns. More people drive there. So we'll talk about what you would expect in different neighborhoods versus other neighborhoods. There's also construction still going on in Lower Manhattan. Otherwise, you see where all the loud music and parties are happening. So how did this map actually get created? We used a data set from New York City Open Data. So New York City has a service, actually I think most areas in the United States have a 311 service now, I think, which is a 24/7 call center, right? So you can easily call up and ask information about your government services. But they also have a complaint line. You can call and complain about things that are going on in your neck of the woods, such as noise. So noise is a popular thing to report. I guess when your neighbor is having a party or making too much noise around, you call a 311 to complain. So I was interested in, given this current social distancing situation that we're in, what would you expect the noise complaint level to be? What do you think the noise level would be in your neighborhood? Or what is it in your neighborhood? Now that you know that you have a call line, is there a reason that you would be calling? Let's see. So the map that we're going to start with is this, this map. So we're going to walk through this and create something that looks like this, something that is telling a more useful story of where noise is occurring. Yeah, I think that's it. So not yet, but I'm going to switch screens now. And if you have those links, I'm going to ask that you pull up both of the EPI exercise and the 311 noise exercise links. So I'm going to turn my video feed off now. Not that it's so interesting to look at, but I'm going to turn it off so that I can properly share my screen with you. Okay, so when you first load this map, you don't see much. You see a picture of the world. This is ArcGIS Online. It's an online-based GIS. On the left panel, you should see where it says Legend, Content, and About. There's also an option Details, or Show Details, and Base Map. I'm going to ask that you first go to the Content tab. And here under Content, you can see those layers that I was telling you about. These are layers of information. There's a checkbox here that allows you to turn the layers on or off. If I turn on the world countries, now I have a layer on the map just displaying where countries are. The EPI data is provided to us in a spreadsheet form. So the original data is here. What I had to do, in case you're interested in it, was to join this table of information that tells us country, EPI score, and all of those 24 variables that I was telling you about that compose the index are in this table. So what I did was I joined this table with the country boundaries to create this layer, EPI 2018 layer. Go ahead and click on a country. If you click on a country, it gives you all that information from that same attribute table in a pop-up. Tells you the name of the country, tells you what continent it's in. Under EPI.current, that's the EPI score for this country. Air.current is the, I believe, air pollution or the air quality score. So all of these are information about the EPI index. So let's go back to the United States, and the EPI score is 71.19. Let's pick Russia. And if you don't know where Russia is, how would you find out where Russia is? Maybe we can turn on some labels. So I'm going to turn on the labels by going to World Countries. Oh, just kidding. Maybe I'm going to change my base map. So there are no labels here, but ArcGIS Online provides some base maps with labels on them. So you can pull up your base map, and maybe let's look at the topographic with labels or terrain with labels. Now when you zoom into Asia, it tells you the name of the country. So here's Russia. The EPI score for Russia is 63.79, just a little bit lower than the United States. Let's see, how about China? China's EPI score is 50.74, a little bit lower. So go ahead and click around, and this is one way that you can interact with this layer of information. But this map is quite boring. So how do you change this, all of the countries being displayed as orange, to something more useful? We're going to go to this option called Change Style. So if you hover over the EPI 2018 layer, there are all these menu items below it. Click on the one that has the 3 geometry shapes and click on Change Style. We have 2 steps, 2 decisions to make. On decision number 1, we're going to change from Show Location Only. You're going to find the EPI current. EPI. And then we're presented with a second option. And by default, we have a map now, the same information, just displayed a little bit different. So now every color represents a different value of EPI. Maybe you don't like the color blue. So let's change the color. We're going to click on the options for count and amount. Then you're going to click on symbols. And this is where you can change the colors to something that you prefer. Maybe a purple. And then you're going to click OK, and then click on Done. Now you have a map that tells you a little bit more information. All right, this is cooler. So we can visually see where the highest EPI scores are and where the lowest EPI scores are. But what if we wanted to, some of you aren't seeing the link.
Yeah, Dara, I'm testing them in different browsers just to try it out. They work for me, but I'm going to have some more folks just report back if they can or cannot get to it.
Okay.
Yeah.
So for those of you who can see what's going on, the last thing that I want to show you is how to find, so visually we can see those countries that have the highest score and those countries that have the lowest score. But what's the max and what's the min? So we can find some easy, or obtain some easy statistics. If you show the table, right next to that Change Style button is a table button. And you're going to scroll over to the right and find that EPI column. And if you click on the EPI column, you're presented with 3 options: sort ascending, sort descending, and statistics. So if you sort ascending, it sorts all of the EPI scores from lowest to highest. Then it tells us this first record, Burundi, if you click on Burundi, it might highlight in the map, has the lowest EPI score. If you didn't know where Burundi was, it's over here highlighted in blue. So there's a relationship between this table and the map. Let's see if we can find out by sort descending what the highest score is. The EPI score, the highest one is 87.42, and it's Switzerland. And Switzerland is over here. If you click on it, click on the record in your table, it gets highlighted in your map. So that's a wide range of values from 87 to 27. What's the average? If you go back to the EPI column and click on statistics, we're able to find the minimum, maximum, average, and the standard deviation of all of the EPI scores. So For the year 2018, the average EPI score was about 56.48. So I hope you were able to follow that quick introduction to ArcGIS Online and GIS and exploring the Environmental Performance Index. I think at this point, I'm going to switch over to the New York City exercise. Or actually, let's pause and take some questions.
Sure. So it looks like most people have the got the ArcGIS for the EPI exercise working. I will definitely share the 311 exercise and the final map in the chat box. For those who may have been had issues with the links, don't worry, this is all being recorded, and we'll definitely post this and share it with everybody so that you can revisit it and follow through exactly step by step with the links that are now working. So Dara, we had a few questions come up when you were showing the your slides and the SEDAC maps, and there was a question about how SEDAC gets all of the data and the images. Is it from satellites? How does that work exactly behind the scenes?
Great question. Behind the scenes, it's a lot of collaboration and coordination between different centers and different researchers. So quite often, NASA's always monitoring the Earth, and there are a lot of satellites out there that are monitoring the Earth. So we'll work with folks to process that and work with information like census data and correlate those. And who does that at CIESIN? Well, we've got a science team, we've got a GIS team, we've got a data services team. We've got several folks working to program and research and manipulate those data in order to tell those data, to tell a proper story. I hope that makes sense. It's
great.
Yeah.
That's very helpful. Thank you.
Sure.
And I will ask one more question, and then we can head to we can do the New York City noise map. So this person had asked, other than the US Census, which you had mentioned, where does data to build maps come from? And I think you gave a good example of NYC Open Data as another example, but in your work, where else does data come from?
Great question. Data's everywhere. Information's everywhere. You might have information, like I said, from a remote sense machine, but we're all walking pieces of data. So you're constantly providing information to applications that are on your phone. There are business databases telling you where businesses are. There are census that occur quite often in the United States. Some of you might have just participated in a census that asks you questions about who you are, who lives in your house. That's a very valuable data set, but there's data everywhere. There are things like the street tree census. So I also teach several classes, and through those classes, I like to teach how do you collect information. So we're walking pieces of information, but we can also collect our own information. So there are lots of surveys out there that you can develop that can collect information. So data and information is everywhere. There are different types of information. There's environmental data. There are socioeconomic information. There's lots of different types of information. I hope that helps.
Great, definitely. Thank you. I think whenever you're set to go on to the next exercise, the links have been shared with everybody again, and I've tested them out. They seem okay, and if we have any issues, I'll let you know, but I think you can go ahead.
Cool, thank you. So this EPI data set was at the global scale comparing countries, but a lot of us are more interested in what's going on in our local area. So the 311 data is, I think the statistic is something like 50,000 complaints a day. So per day, that's at least 50,000 records in your table. So that's a lot of information to handle, which another part of another answer to that question previously is New York City has an open data portal, which gives you access to all of the New York City government agencies' data. And so that's where I found this. Before we talk about how to work with that data, in this map, it's not, if I turn on all these points, looking at the New York City boroughs in purple isn't really going to be helpful for us to explore where these complaints are occurring. So let's go ahead and change the color of the borough boundaries. We're going to do that by underneath the New York City borough boundary label. Oh, if you are not on the content tab, make sure to switch from legend to the content tab. And then under New York City borough boundary, you're going to go ahead and click on the change style. And we're going to click on options for the location only. And then you're going to click on symbols. And here you can change the color. I'm going to change the fill color to no color. And I'm going to keep the outline as maybe the gray that already exists. And you can see the line width is 1.5. In GIS, you'll find that there are menu and menus and menus of options. So now our symbol is just an outline of the borough boundaries. And now I can't see them on the map. So I'm going to go ahead and change the base map. And for this exercise, I'm going to choose a dark gray canvas. You can choose whichever one you like. So I'm going to start at the top here. We're going to talk about the first layer called the 311 calls between May 1 to 8. These are all of the individual calls that were made. So when you make a complaint, it's associated with a location, maybe your house or where that complaint is actually occurring. You can see there's a lot of points, and it's really hard to make sense of that. You can kind of see that there's a lot in Manhattan, there are a lot in Bronx, there are not so many in Staten Island, but statistically speaking, you know, that's not really telling us much. So what I did was I made another layer, the second layer, and we clustered them. And so there's this option, there's a blue kind of circle button, cluster points. If you click on that, it creates this. This map clusters all of those individual points into kind of buckets. And so the biggest point here has about 818 points. The lowest point has 1. So it's just easier to interpret what's actually going on here. The coolest thing about this data set was actually the most complicated thing that I said previously, that there's 50,000 or so requests or complaints a day. So how do you make sense of that? Because there's time associated with this data set, we have a time slider at the bottom of our map. I've set it to show us 311 calls per day. So you can go and click on the play button, and it'll show us every day what the calls look like. And we can start to see a pattern of how complaints change over time. I believe May 1st was a Friday or Thursday. So you can see also time of day might have an impact on when you're calling, what you're complaining about. Maybe if it's nighttime, you'd be more inclined to complain about a party, a loud noise, versus daytime where it might not affect you so much. So this is a great function in this application. So try to observe, what kind of patterns do you see? Actually, can we ask these folks a question, Cassie? What kind of patterns are they?
Yeah. So you want them to comment on the types of patterns that they see as you're playing these, or going through this and playing the different white circles that pop up?
Yeah.
Okay. Great. Yeah, so we'll post that out to the group who's watching. What do you notice about the map? There's a bit of a delay between Zoom and YouTube, so we'll give them a little bit of time. Can we okay, it's continuing to play. Okay, so let us know what, if any patterns you see happening on the map with respect to the cluster points noted by the white circles. So Dara, while they're doing that, while they're watching that, I might interject here with another question. So someone had asked about the map that you showed from NOAA that you said was one of your favorite maps, about the 150 years of cyclones. How was that map made, and what kind of work was involved in putting that together?
Great question. Well, unfortunately, I didn't put that map together, so I'm not entirely sure. But the process has to do with a lot of data processing and cartography. So kind of like what we're doing here with the 311 data, you start out with a lot of points that kind of make no sense and are hard to interpret. So you use different GIS functions like this cluster analysis to make the information more useful, interpretable. Then you play with things like color and font and scale. So it becomes then a design exercise. How do you best communicate this complex information to a wide variety of people?
Okay, great. So we have some answers coming in terms of the patterns that people see. It seems like there's more and more calls every day. Potentially on weekends is when more people seem to be submitting complaints. More calls every day. Every 2 days or so, there seem to be more calls. Those were the general answers that came in.
Interesting. So those are great observations. And if you notice, those observations are throughout the whole city. So are there patterns that are different by neighborhood, or if we fine tune by type of complaint? So we're going to uncheck that second layer now, and we're going to turn on the third layer. And so for this layer, I summarized the calls by neighborhood. So we're going to take this layer, and you're going to go back to the change style. And you're going to change the attribute to count of points. And I'm going to leave everything default for now. So in this case, this isn't a clustering of points. I took all of the New York City neighborhoods there's about 42 of them, and counted how many calls there are in each neighborhood. So you can click on a point here, and the pop-up will tell you there are 1,927 points or 311 calls in East Flatbush for the week of May 1st to May 8th. And there's also a chart that we obtained at the bottom of this pop-up that tells us about what days these complaints are occurring, because this is a cluster of 8 days or so. So play around. This is a little bit more useful, right? So it doesn't give us all of the information at once. Now we've filtered it down or summarized it by neighborhood, which is more useful for some of us. So it's the same with all those big global data sets like the 150-year cyclone data set. We have to filter it down and make it more useful so that we can actually understand what's going on. So now we know by neighborhood how many total 311 calls there were. But this exercise was supposed to explore noise. So what I did was I filtered all of the complaints by type. And so if you turn on the noise complaints by type, and we're going to find that filter button. It's the yellow icon with the filter on it. I've already done this for you, but you can play around with maybe other types of complaints as you explore on your own. But I have a complaint type. So in this data, in this 311 data set, there are lots of different types of complaints. Noise is not just one of them. You can have noise in general, you can have noise commercial, helicopter noise, house of worship noise, noise in a park, noise in a residential area, noise on the street and sidewalk, noise in vehicle. So I created this filter that looks like this, where the complaint type is equal to each one of those different attribute types. And that filters down to this data set, which is it's still a lot of points and hard to make sense of. So we're going to change the way that we visualize this data. We're going to change the style. And we're going to look at the complaint type. So you're going to change the attribute to complaint type. Now we're getting something. Now every color represents a different type of noise. This is telling us something a little bit more interesting. Lots of noise in residential areas, because I see lots of pink. A little bit of green, which is vehicle noise. So the complaint type has another attribute that can fine-tune this, which is called the descriptor. So if we change from the complaint type to descriptor, this information tells us the type of noise that they're complaining about. So here we go: loud music, banging, pounding, loud talking, engine idling, loud television, noise, ice cream truck, all those different types of complaints. So I'm going to leave it with the descriptor being mapped. I don't quite like these colors, so I'm going to change the colors by clicking on options under the type. Changing the colors here is a little bit different. It's this horizontal change all symbols button. And under the fill option, just click on fill. You can choose different color ramps here. And I'm going to click OK. And I'm going to click on done. Now I have a map of all of the noise complaints by type. And I can't really see them, so I'm going to change the base map to a lighter gray color. Okay, so this is a much more interesting map, telling a much more interesting story. The last thing I want to show you is noise complaints looking at a heat map. If you click on the heat map, it shows us where the density of complaints are occurring. So you can zoom in and out of your map using the plus and minus button, and this heat map will change. So it's just a different way to visualize the same information. And you can see those blue blobs are a dense population of these calls. I think the last thing I wanted to show you was how I got this final map. And for that, I think we're going to go back to the 311 calls summarized by neighborhood. And we're going to change this style from count of points. Sorry, we're going to change it to the types. No, I think we're just going to leave it there. So I'm going to leave you all with that and take some questions.
Okay, great, thank you. Dara, do you mind if we turn off the share screen and we can see you again? Perfect. Definitely a lot of great information. I know that for some of our viewers, if you had a difficult time with links or following along, we'll definitely share the recordings of these and make sure that everyone gets, and these links are good. You know, you don't need, they're not going to be taken away anytime soon. So we'll make sure that everyone gets these and has a chance to play around with the maps a little bit more on your own. So in the last couple of minutes, there were a couple questions about so there was one question about how we can make comparisons with the maps that we make. For example, this New York City one with the noise, how we can make comparisons of these maps to maps created for other cities. How might we go about doing that?
Good question. So for other cities, you're going to have to check into their 311 services and see if they have an open data portal so that you can obtain that data. I don't know much about that, but you would start with the data. And then what I've showed, the GIS tool that I was showing you is called ArcGIS Online. I created that using a license that I have. If you're an educator, I'd be happy to instruct you on how you can obtain an educator license. But all of you can obtain a public free account. So you'd have to sign up for an account in order to add your own information to those maps and start working with it that way.
Okay, great. And there was a question about whether or not you could use fictional data just to test out the software.
Sure. I would suggest not using fictional data, but just go ahead and find a GIS clearinghouse where you can, so ArcGIS Online has a living atlas, which shows you or gives you a database of authoritative data sets from places like NASA and NOAA and US Forest Service So you don't have to create fictional data. You can use existing data for free.
Okay, great. And the next question was about whether or not GIS can be used to enhance teaching students about climate change.
Absolutely. I'd be happy to help you with that. We have a lot of climate information. We at Columbia University, we work with IRI and CIESIN in order to monitor climate change. So we have plenty of data sets, everything from temperature to, I can't think right now, but yes, climate change is very applicable to use in GIS.
Great. And are there, do you have some examples of other maps on ArcGIS that people can explore using the some of the techniques we tried out today with different layers and changing colors and sorting by types and counts?
Some more examples?
Yeah.
Really, you can map anything. So if you're talking about fiction, you can create a mental map, you can create a fictional map of a fake neighborhood. You can figure out, you can map anything. You can map restaurants, you can map your favorite food, you can map migration, you can map hazards, you can map anything that you have a potential location for. Yeah, don't be shy. Maps don't have to be of tropical cyclones. They can be of anything you like.
Okay, great. So there's some questions about follow-up, and we'll make sure that when we send the link out for the video, some of our participants may want to follow up with Dara, and so we'll make her info available, and we'll make sure that the recording goes out and you can try out the links if you weren't able to join us for live stream, or if you weren't able to follow step by step. Again, if you have any questions, let us know. Dara, any closing remarks for our participants? Anything else you want to cover?
I would like to say thank you. I have a thank you slide.
Great. Yeah, and I think your email address was on the thank you slide. I think I saw that.
Thank you very much.
Okay,
if you have any questions or any interest of what you can map, what you can't, how do you do it, feel free to reach out. And I hope this was of interest to you. And I hope to see your maps in the future. If you guys create some really cool things and want to share, I think that would be awesome. Maybe if you figure out some noise patterns that we didn't explore today, you can send it to Cassie or myself, and I'd be happy to take a look. So thank you for your time.
Okay, perfect. Thank you. Well, it's 3 o'clock, so we're going to end things there. Dara will be back on Wednesday, actually, for part 2 of this. She's actually probably going to go over the same sort of maps and some of the same techniques, but it'll be geared towards an older crowd of students. So if you do want to join us again, just make a note that it is going to be for high school students. So we'll probably ask some additional questions, play around with additional techniques. But she's also going to be doing that. So thank you, Dara, for your time and for sharing this with us. Thank you to our viewers. And if you have any specific questions, just email me and we will be sure to address those. So enjoy the rest of your afternoon, everybody, and thank you for joining us again. Bye.
Thank you.